Hi geographers, so today I'm going to tell you about a really important graph in geography, something that shows how a river responds when it rains. So along the x-axis here we have time. Now a storm hydrograph normally goes over 2 to 3 days in total. On the y-axis we actually have two sets of labels. The first one that I'm writing in here is rainfall in millimetres. The second y-axis shows the water level in a river, otherwise known as the discharge, measured in meters cubed per second, or cumex. What the storm hydrograph does is it shows how this water level changes when it rains. Since rainfall is a set of discrete data, it's plotted as a bar graph, whereas discharge is always plotted as a line graph, since it represents continuous data. Make sure you look these up if you're not sure what they mean. Now you can see that when it does rain, the river responds by increasing its discharge. When it goes up, it's called the rising limb, and when it falls again after the storm, it's called the falling limb. The very top of the peak is the peak discharge. Q is the symbol of discharge, so we're going to be using that in this presentation. You can see here how full the river can get, and in some cases it actually overflows its banks. You might see a little line on your storm hydrograph indicating the bank full discharge, and this would be when the river gets right to the top, and if it goes beyond that line it means there's a flood. Now it's really important that we learn all these key words and phrases, so what I'm going to do is write a list at the side so we won't forget them. Another really important key term and concept of the storm hydrograph is the lag time, and that is the gap between the peak rainfall and the peak discharge. So why is there a delay? Let's take a look. Here's some rain, lots of rain, and here is our river. You can see that only a very small amount of rain actually falls directly into the river channel itself. So it wouldn't make sense if the river level suddenly rose instantly as soon as it started raining. Most of the rainfall actually reaches the river via other processes which you would have learnt about when you did the drainage basin hydrological cycle. When it first starts raining, the water will infiltrate the soil, and assuming it's permeable, it will percolate down into the rock below. This is called groundwater flow or base flow, and it's the slowest transfer out of the ones you're going to be talking about. So let's draw it onto the graph. This part here, going up very slowly, is the base flow. And you can see that it keeps rising, keeps adding water to the river long after it stops raining. As the rain keeps falling, the soil will start to fill up with water and become saturated, particularly if groundwater stores become full or if the rock is impermeable. The water will then reach the river via through flow. So let's just add that onto our graph here, and you can see this is faster than the groundwater or base flow. Finally, the third way that water can reach a river in a drainage basin is if surface storage builds up and then flows over the ground as overland flow. This process is much faster than the other two, and this is the one that can often lead to flooding, particularly in urbanised areas. So let's add this final component onto our graph and add a few more keywords here at the side. Apologies, I forgot to mention peak rainfall before, but that's simply the time when the rainfall reaches its maximum and where you measure lag time from. Okay, so now we know what a storm hydrograph is, we get to the really interesting part, which is the different shapes that a hydrograph can take. Now you can see the one on the left can be described as a flashy hydrograph, whereas the one on the right is delayed. Flashy hydrographs are characterised by a very high peak and very steep rising and falling limbs. Whereas delayed hydrographs tend to have a long lag time, a lower peak, and a much shallower curve overall. Let's add these words to our list as well. So why do these hydrographs have different shapes? Well, hopefully it's obvious to you by now that the one on the left will have lots of overland flow, whereas the one on the right will have mostly through flow and base or groundwater flow. Now, I'm not going to go into a great amount of detail about why this is, but hopefully you know from studying the hydrological cycle that drainage basins with flat land, lots of trees and permeable rock will have much slower transfers than areas with urban surfaces, steep slopes, places that have impermeable bedrock underneath the soil, and possibly have very thin soil that can be easily saturated. Okay, so let's take a look at some exam questions. Now, the first thing you have to do, as with any question in the exam, is make sure you read every word very carefully so you know exactly what the question is asking you to do. This particular question, it contains two figures, okay? The first one has two drainage basins. So let's have a look. We've got drainage and geology on the left, so that shows the rivers and the type of bedrock underlying. And then B shows the drainage, again it shows the rivers, but also the land use this time. So are there trees, for example? Is it bare ground? It could be arable farming, it could be grassland. All of these things are going to affect how the river responds when it rains. Now make sure you read the figure labels, okay? As you can see, this is an upland drainage basin in the British Isles. I can't tell you how many people got this wrong and thought that it was two separate drainage basins and lost a lot of marks because of it. So just to clarify that, Figure 2 shows two different characteristics of the same drainage basin, okay? One shows rock, the other shows land use, but it's the same set of rivers each time. Now the next thing to notice is the three hydrograph gauging stations P, Q and R. This is where discharge is measured. This is what links the first set of diagrams to the second one, or figure 3, which, if you read at the bottom, is storm hydrographs for the three gauging stations P, Q and R. So it basically shows the water level for three different places in the same drainage basin. It is not three different drainage basins, but you can see from the map above that they're all in the same one. Now for the first question, you have to compare the storm hydrographs for stations P, Q and R as shown on figure 3. This is worth 5 marks. This means that it's level marked, okay? Remember that questions that are 4 marks and below are point marked, but if it's 5 and above, you can't just write 5 points and get 5 marks, but it's marked on 2 levels. So to get to level 2, you need to have a high level of sophistication, high level of understanding. So how can we do this? Before we answer, one thing that I find really helpful with graphs like this is to colour code them. So I'm just going to put here P in red, and then we'll put Q, which is second, but it's actually bottom on the graph, which is why it's so confusing. We'll put that one in purple, and then I'll put R in green. Okay, a lot of people get confused between R and Q because they're the different way around of the key. So make sure you don't fall into that trap. Now, all you have to do for this question is to say how P, Q and R are different from each other. You don't need to explain why they're different, you just need to describe the graphs, okay? So don't try and put in any explanation. If you're not sure about this, just look ahead to the next question and you'll see why. So to get up to level 2, the first thing you should try to do is use keywords. For example, instead of saying that P has the highest water level, you might say that it has the highest peak discharge and use that key phrase. Secondly, you must obey the command word of the question. So in this case, it says to compare. Therefore, you should try to use comparative statements in your answer. You can do this actively by using words such as whereas, conversely, or however. Next, if you're given a graph in any question, you should always try to use and even manipulate the data from the graph. If they give you a graph with numbers, they like you to use the numbers and even to do basic calculations with them in your answer to show your understanding. So for example, P has the highest peak discharge would be a level 1 statement. In order to make it a level 2 statement, you could add of 70 cumecs, okay? So you see you're adding that little bit more detail, and that's the sort of thing that can push you up to the next level. Now, to give you an example of data manipulation, you could say that Q peaks at only 21 cumecs, more than 3 times lower or less than a third that of station P. When you do read numbers off a graph, make sure that you use a ruler, as the mark scheme can be really picky about accuracy. Finally, you must refer to all 3 lines on the graph to get to level 2. The next thing you have to do is to suggest reasons for any differences that you have observed between hydrographs P, Q and R. In other words, now you have to say why, you have to explain why they are different from each other. Now this question is a bit more difficult because it requires you to link the 2 diagrams together. It's worth 7 marks, so it must be detailed. Again, you must use keywords in your answer, so use the list that we did at the beginning. You could structure your answer by looking at geology first and then land use, so try to make that structure really clear in your answer. And again, you must use comparative statements because the question is asking you about differences. Now you must use the diagram, okay? So don't suggest any reasons that are not obvious from the diagram. Don't start talking about, for example, steep slopes or urbanisation. I'm just going to label my hydrographs again to make it clear when I answer, and then we'll have a look at some example answers. So number 1, P is higher than R, which is right because it is high up and must have steep slopes compared to R, which is lower down. Q is on permeable rock, so the rain can soak in. R has lots of trees that absorb all the water, but Q has moorland, which absorbs less water. Finally, at R, the water can't soak into the ground, so it has less water than P. The first thing I would say about this answer is that you can't tell on the diagram that there's any steep slopes, okay, so don't make stuff up. Secondly, they've really missed an opportunity to use keywords. They've said soak in, but they could have said percolate. And then they haven't developed this point, okay, they haven't linked it to the hydrograph. They haven't said what impact the fact that it's impermeable will have on the shape of the hydrograph. They've made the same mistake in the next sentence, and overall their answer doesn't really have much structure. It's not very clear, and there's definitely not enough detail to get 7 marks. So let's have a look at another answer. This student has said the first reason for the differences is that P and R are on impermeable shales, whereas Q is on permeable limestone. This means that rain falling at P and R will travel to the river by through flow and overland flow, whereas at Q, more water will percolate down into the rock and travel to the river via groundwater flow, which is much slower. This explains why Q has a much lower peak discharge and a longer lag time. By using the phrase the first reason, they've given their answer a clear structure and they've used words from the question. Secondly, they've used comparative words such as whereas. They have clearly developed the points they're making by using the phrase, "this means that." You can see that they've used lots of keywords in their answer, such as through flow, overland flow, groundwater flow, percolate. They've fitted lots in just to one paragraph. And they've also used specific information from the diagram. They haven't made any assumptions. Now, that's only part of an answer, so let's see what else we could look at. Now, if we look at R first, R is situated in a coniferous forest. So there's trees which intercept a lot more rain than grass or pasture, for example. This would do two things. First of all, there would be more evapotranspiration, so less water would reach the river in the first place. This would explain the lower peak discharge. Secondly, this means there would be more stem flow and through fall. Now, this is much slower than if it just falls on bare ground. This would slow down the water and create a longer lag time. Now, let's look at Q. You can see from the diagram that it has only one tributary leading into it. R has 2, whereas P has 3. So it would make sense that water reaches P the fastest, and therefore P has the shortest lag time, and the water reaches Q the slowest, and so Q has the longest lag time. So you can see on the diagram here the 3 tributaries for P, 2 for R and 1 for Q. Now, I'm not going to go into any more explanations that you could give from the diagram, but I hope these examples have given you a good idea of how to reach level 2 in this question. Okay, so let's look at one final question, which involves practicing your graphical skills and drawing hydrographs. The question says that you need to draw sketch hydrographs on figures 1A and 1B to show the contrasting effects of each of the 2 rainfall periods on river discharge. And this question is worth 3 marks. Now, the first thing to remember is that a hydrograph is a line graph. So you don't need to be adding any more bars onto the diagram. Now, if we have a look at the question, we can see that the 2 graphs are from the same river. It's just that they show different periods. It's not 2 different rivers, which a lot of people think at the beginning and then get confused about. Some of the common errors that people encounter when answering this question is, firstly, they don't give the river any lag time. Okay, they don't give the water any time to reach the river. So they draw something like this. So as soon as it rains, the river levels go up instantly. And we already talked about why this is not the case. The second mistake people make is that their river dries up. So by this, I mean that they start and end their hydrograph all the way at 0. This indicates that there's no water at all in their river in between rainfall periods. Now, while this might happen in a desert, remember that this is the River Severn in the UK, so that's very unlikely to happen. The third issue is inaccuracy. Now, you can see in figure 1A, the peak rainfall is around 5mm compared to 34mm for figure 1B. So evidently there's a lot more rain in figure 1B. Therefore, there should be a lot more discharge in the river. Unlike in this sketch, where the second hydrograph isn't really that much bigger than the first. So how can you get your 3 marks for this question? Well, firstly, the hydrographs have to be correct overall. So let's draw them on. Now you can see that I've started and ended both hydrographs at the same level, because remember, both hydrographs are the same river, so it makes sense that they would start and end around the same level. Secondly, I've made sure that my peak discharge is after my peak rainfall, so I've given them some lag time. If they go down to 0, you can't get more than 2 marks. So once you've got them correct overall, you can get 1 mark for making sure that your second hydrograph has a higher peak discharge than your first hydrograph. You can get a second mark for making sure that the first hydrograph has a longer lag time than the second. And then finally, your third mark would be for accuracy. Okay, so the peak discharge for the second graph needs to be at least 3 times as high as the first one. And that's because the peak rainfall on the second diagram is so much higher than the first. Now for the second half of this question, you have to suggest reasons for the differences in the shapes of the hydrographs that you have drawn. Now this is worth 3 marks, which means it's point marked. In other words, you need to give 3 clear reasons for 3 points. And you must explicitly link these reasons to the hydrographs that you've drawn. So let's draw our hydrographs on again. Now you can structure your answer by firstly describing the shape of each hydrograph, and then you can give a reason why it's that shape. So for example, you could say that 1A has a longer lag time because peak rainfall didn't even reach 10 millimeters, meaning that most of the water would have infiltrated into the soil and travelled to the river slowly via through flow and groundwater flow. However, 1B has a shorter lag time because it gets a lot more rainfall, over 3 times as much. This would saturate the soil, leading to overland flow, which would reach the river a lot faster. Finally, 1B has a much higher peak because it receives so much more rainfall over the same period of time. Now you can see that this answer has a really clear structure. First they have described the shape of the hydrograph, for example longer lag time or higher peak. Then they have given a reason to explain the shape each time. Finally, you must always use keywords, and you can see how many have been used in this example here. So we've got peak rainfall, infiltration, through flow, etc. Make sure you have 3 clear reasons, 1 for each mark. And that's it. So thank you very much for watching. I hope you found that helpful. Please leave me a comment below if you have any questions or suggestions as to how I can make these videos better. See you later.
This video was brought to you by Geogarific.com.